Abhi,
technical glitch.
okay, no problem. Uh, Good morning, everybody, and welcome in the 3 days training program on grid discipline, fault analysis, and management operation of power station. It is a very important program of protection system. And for delivering the lecture today, Mr. Patki, S.G. Patki, he is with us, and most of you must be knowing that he is a very renowned faculty and international level faculty. I welcome Shri Patki Sahab in this program. And namaskar sir. And all the participants का भी मैं welcome करता हूँ. And very good morning all the participants. And participants, I am informing that your ED, Shri Ashok Kumar ji, T&HRD ED, he is also with us today. I welcome Shri Ashok Kumar ji for joining this training. And very nice of you that you have joined this program. And every time I say that when senior officers are attached with these training programs, and when they are taking the interest, so definitely the training's value goes very up. And today, as I already requested all the participants that be attentive very much and all the time remain in the training all the 3 days, because it has been come to our notice that your CMD is very attentive for this program, and he is very serious for these training programs, and he must be watching this training program today. And definitely he will watch not only the performance of our training and faculty, as well as he is more concerned about the participation of the participants. So be attentive and be very attentive, and ask a number of questions and be participative. Uh, Once again, I welcome Shri Ashok Kumar ji, and before requesting to say a few words, I will give introduction of our faculty, Shri Sanjay Patki ji. He is a former Vice President of Tata Power, having 42 years of experience in generation, transmission, distribution, and technical services. He is, I can say that he is a complete package of the protection system, and it is our opportunity for all of you that he is taking lecture for this training program. And on our special request, Shri Patki has become ready to participate this training program. Mr. Patki has contributed several technical papers in several committees, national and international levels. He was the chairman of SIGRE India Committee on Protection and Automation, NSC B5, and was awarded as distinguished member by SIGRE Paris during 2016. He is recipient of CBIP Award for excellent contribution to power system protection and automation during 2018. He chaired the expert group of CBIP for preparation of manual on power system protection and automation. One more thing I can say, that you all must be aware that there was a massive blackout and grid failure in July 2012. And after that, a high-level committee was formed so that such programs, such mishappenings should not be repeated. And a high-level committee was formed by Government of India to look after the root cause of that failure. And you will appreciate that Shri Patki was one of the member of that committee. And after several meetings, a guidelines was formed, which is now already implemented all over India to save the grid. My saying is that only I want to say that Shri Patki is with us, and we have great opportunity to ask number of problems, to discuss our number of things which we are facing at our power stations. It would be better that you will, if you will participate. Once again, I welcome Shri Patki Sahab, and she, regarding Shri Ashok Kumar ji, he, myself and Ashok Kumar ji already worked together at corporate office also, and a number of times during my service. You participant must be knowing that I was also in the NHPC also and retired as general manager from there. And we have worked together, and he is a very nice person, and now he is ED of T&HRD, and I hope that with his guidance and with very good control, you will be very much able to, that at the end HRD will achieve the number of to giddy heights of the sky. I can say that. Welcome Ashok Kumar ji. And now I request Ashok Kumar ji, please say a few words for the participants and regarding the training program. Thank you.
Very good morning and welcome to each one of you, where we are humbled to know that Mr. Sanjay Gopal Patki is here, a well-known person, eminent person in power sector of India. And I also welcome and pay my regards to Mr. S.K. Lamba, advisor, power, CBIP. And my friends, young future, young aspirations of NHPC participants, around 50 participants, out of which 4 or 5 participants are not able to be in this meeting because some machines things are going on in their respective power stations. So in the morning only we got this news. So how fortunate, and really I am humbled by the presence of our faculty. I will call Professor Sanjay because today he is in that mode. He is going to his life experiences, how he worked more than 40 years, beside giving the technical know-how, sharing know-how, his experiences. So it's a very good opportunity for each one of us to learn. So whenever some senior person like Mr. Lamba or Mr. Sanjay is there, it's a really honor for us. It's a good fortune for us. It's a wonderful opportunity for us, for younger generations, to seek them. Whoever seek the way, they become master in life. So this program, where the eminent top institute of technical institute of India in power, CBIP, has organized this program, Grid Discipline, and where the top faculty of India, well-known person of India, having rich experience in power sector, Mr. Sanjay is there. So what there is to achieve? So I expect and I know all my participants are committed, are very sincere for NHPC's growth. Time to time, when some training program is being organized, it's an opportunity for each one of us to update what's going in market. As Mr. Sanjay has worked in Tata Group private sector, and over the 40 years, what were the crucial junctures, what happened in India, the way Mr. Lamba has shared in 2012. So all those experience will be a boon for the younger generation to learn, so that in future, if some or the other eventuality happens, occurs in India, so we can take care. So we each participants are shouldering the responsibility of taking nation ahead for next 30-40 years. So next 30-40 years are very important for power sector, for giving a impetus to NHPC, to our nation's growth. So we all know NHPC is a premier institute in premier organization in India for power generation. So when a rich experience and youthful energy combination is there, so what cannot be achieved? So whatever the challenge universe throws at us, we can handle it. Yes. So I don't request, I don't expect. I know each one of our participant has have burning this desire to work for nation, work for society, and NFPC has provided them a forum. CBIP has provided them a forum, and Mr. Sanjay is there. So what cannot be accomplished today? Today is a very good day, and I really thankful to get associated with today's event. I wish each one of them all the best. And I also, in the beginning only, I am thankful to Mr. Sanjay and Mr. Lama for being here. Anything, please let me know. I will be there. My team, TNHRD, will be there at your thing. Anything, we will be there to resolve it. Thank you so much and all the best. And I pay my regards to today's faculty, Mr. Sanjay. Thank you so much, sir. Thank you.
Thank you, Ashok
Thank you.
Kumar ji.
Thank you.
So nice of you. And now, before starting this program, as per NHPC's requirement, one opening test we will conduct, and I will request Mr. Ravinder to he will share the link with you, and I request you all that kindly participate in that question, and around 15 questions are there, and within 10 to 15 minutes, 10 minutes, kindly attend all the questions, and after that we will start the program. And same thing on closing day, again one test at the last of the completion of the training, one test will be conducted. And today and tomorrow Mr. Patki is with us, and and on 10th last day Mr. Kamin Dave, he will with us. He is also an international level faculty, and you must be knowing him also. And now I request Mr. Ravinder to kindly share the link of question papers.
Yes, sir. It's already said, sir.
Okay. एट लोग काइंडली पार्टिसिपेंट, आप लोग पार्टिसिपेट कीजिए इसमें, जल्दी से जल्दी इस क्वेश्चन को पूरा कीजिए, और जो भी डिफिकल्टीज क्वेश्चंस में नहीं आए, जो आएगी उसको बाद में ड्यूरिंग द सेशन भी डिस्कस किया जाएगा, और सेशन के बाद भी आप पूछ सकते हैं उसका। मेरा एक और रिक्वेस्ट रहेगा कि जब सेशन शुरू होता है तो एक टॉपिक को हम खत्म होने दें, आफ्टर completion of that topic, जो भी आपके questions हैं, you can raise and you can ask any clarification from Mr. Patki, and you will definitely found that you will get immediate reply or convincing reply from Patki साहब। तो एक हर जो भी टॉपिक है उसके बाद ये क्वेश्चन होगा, और आफ्टर दैट ये सेशन जो चलेगा 12:15 बजे तक चलेगा, उसके बाद एक क्वेश्चन आंसर आप लोग नोट भी लिख करके रखें, और उसके बाद आप पूछ भी सकते हैं उसमें, या चैट बॉक्स में आप डाल सकते हैं क्वेश्चंस को। काइंडली स्टार्ट द प्रोग्राम में क्वेश्चंस प्लीज। अशोक कुमार जी, यदि बीच बीच में आपको टाइम मिले तो आप बीच बीच में भी ज्वाइन करके देख सकते हैं कि कैसी ट्रेनिंग चल रही है।
Sure, sir.
I know कि आप
I'm
I know कि
humbled by
you
your
are
proposition.
very
Yeah.
busy, but if you will get time, in that case you can
Sure.
join us at any time.
Sure, sir.
Uh,
Sure, sir. Thank
Thank you.
you, Professor Sanjay. Thank you, Lamba Sahab. Thank you, each one of you. Thank you.
Thank you.
Thank you,
Ashok
Ashok
Kumar.
Kumar ji.
Thanks a lot.
Namaskar.
सर मैं मानस कुमार डिंडा बोल रहा हूँ। क्वेश्चन लिंक नहीं मिल रहा सर, कहाँ मिलेगा सर?
क्वेश्चन लिंक
सर लिंक सर, हाँ सर मैं एक्सप्लेन कर देता हूँ सर। मैंने लिंक आपको एक तो इसमें जो चैट बॉक्स है ना सर, इसके चैट में देखिए, उसमें भी एक लिंक शेयर किया है मैंने, और जो व्हाट्सएप ग्रुप बनाया है हमने, उसमें भी हमने आपके लिए लिंक शेयर किया है सर।
अच्छा सर।
आप लोग चैट बॉक्स से ले लीजिए, चैट बॉक्स से सबको मिल जाएगा। हो सकता है कि ग्रुप में मेंबर बहुत आदमी जुड़े हुए ना हो।
हाँ इसमें भी शेयर कर दिया सर मैंने, चैट बॉक्स में देखिए अभी आप चैट में।
ओके।
सर इसमें तो चैट्स बॉक्स दिखाई नहीं दे रहा, एक्चुअली मैं मोबाइल में ज्वाइन किया हूँ सर।
सर आप ग्रुप में अवेलेबल हैं?
यस सर, मैं मानस कुमार डिंडा बोल रहा हूँ।
ओके, मैं ग्रुप में लिंक अगेन शेयर करता हूँ टेस्ट का।
टेस्ट लिंक को फिर से डाल दिया गया है इसमें, ग्रुप में दूसरी बार भी डाला है, काइंडली चेक कर लें आप लोग। अब लिंक सबको मिल चुका है कि नहीं? अभी भी किसी की प्रॉब्लम है?
यस सर, मिल गया, थैंक यू सर।
ओके ओके, थैंक यू। और मिस्टर रविंदर, मिल चुका है सबको, अभी लिंक मिल चुका है, लेकिन आप कांटेक्ट में रहिए यदि किसी को कोई प्रॉब्लम आती है तो। काइंडली विद इन 5 मिनट्स करीब अपने खत्म कर लीजिए अपने क्वेश्चन पेपर्स को, जितना भी हुआ है उसके बाद उसको सबमिट कर दीजिए 5 मिनट के अंदर। ऑल क्वेश्चन विल बी डिस्कस्ड ड्यूरिंग द ट्रेनिंग प्रोग्राम। ये अभी तक 17 पर्सन्स ने अभी तक केवल सबमिट किया है अपना क्वेश्चन पेपर। तो काइंडली रेस्ट भी जल्दी से कर दें, 1 मिनट के अंदर, 2 मिनट के अंदर, जितना भी हुआ है उतना सबमिट कर दें। बाकी जो डिस्कशंस हैं बाद में ड्यूरिंग हो जाए, अदरवाइज टाइम काफी कम रह जाएगा डिस्कशंस का। तो आफ्टर 1 minute we are closing this, and kindly submit within that period. पटकी साहब, अभी 27 ने ऑलरेडी सबमिट कर दिया है टेस्ट अपना, तो नाउ वी कैन स्टार्ट। और मेरा ये रिक्वेस्ट रहेगा, जो बचे हुए आदमी है वो भी 2-4 मिनट के अंदर अंदर साथ साथ जब तक ये शुरू होता है, प्रोग्राम भी शुरू हो रहा है, साथ साथ वो भी अटेंड करें और अपने क्वेश्चन पेपर को भी सबमिट कर दें, क्योंकि ये भी बाद में हम देखेंगे कि कितने आदमियों ने टेस्ट दिया है। ये दैट इज आल्सो बीइंग वॉच्ड बाय योर मैनेजमेंट। तो काइंडली जो बचे हुए हैं वो भी अपना क्वेश्चन जल्दी से जल्दी दे दें, सबमिट कर दें। तो पटकी साहब, काइंडली भी इसको वी कैन स्टार्ट नाउ।
I will share my presentation.
सो अभी विजिबल नहीं है सर।
Presentation visible to everyone?
नो नो सर, अभी नहीं विजिबल हो रही सर।
यस
यस, अब आ गई थी।
हाँ?
नहीं, फिर चली गई।
फिर चली गई सर।
सर आपका ना ये थोड़ा सा मींस नेट थोड़ा स्लो हो रहा है, तो आप अपना अगर वीडियो भी ऑफ कर दीजिए सर, उससे थोड़ा सा बेटर हो जाएगा। पटकी
Okay.
सर, अभी आपका प्रेजेंटेशन विजिबल है सर, अभी आप इसको बस स्लाइड मोड
Okay.
करना पड़ेगा।
It's not going into Okay, now it's properly visible.
Yes.
Yes, sir.
Yes, sir.
Okay. So
Yes,
good
sir.
morning, everyone, and welcome to this workshop on grid discipline, operation management of the powerhouses, and fault analysis. Let me give the outline of the program. When we talk about grid discipline, basically all the participants in the power system, whether it's a generation company, transmission company, or distribution company, and the load dispatch centers, they have a role to play, which has been defined in the Indian Electricity Grid Code. So what we'll be discussing today, what are the provisions of the grid code within which all the participants of the power system need to operate, and what are the operation policies, procedures, and capabilities by which they will try to maintain the grid parameters within its control. So that will be the first topic of discussion today. Then in the afternoon today, we'll discuss the specifics of voltage control, frequency control, and how the power system stability needs to be maintained. So that will be the topic for the afternoon today. After looking at these two critical aspects of discipline as well as the grid code, tomorrow we'll look at what are the different types of power system contingencies and how they are handled by different protection and control schemes, and including the schemes which are implemented in powerhouses, so that again the grid parameters can be kept under reasonable control. And finally, tomorrow afternoon, we'll see the protection schemes which play a critical role in controlling the grid disturbance as well as preventing the grid collapse. And what are those protection schemes? So this will be the outline of today and tomorrow's program. And third day will be, as Lambaji had said, it will be devoted to fault analysis and management by Mr. Kamin Dave. Through CBIP and along with Lambaji, I had opportunity to visit almost most of the powerhouses of the NHPC, where we have conducted protection program as well as this grid program. So the presentation today is taking into account the feedback and our discussions at various powerhouses, and also some of this program was also conducted in CBIP in Delhi in physical mode before the COVID. Because of now this program is converted into the virtual mode. The presentation which will be shared with you will have all the details, but we'll try to control the time and learn the key aspects. So that is the outline of the program. Lambaji, any comment on this outline? This is okay?
Yes, it's okay, sir.
Yeah. Now, as I said, when we talk about grid discipline, it is a grid operation code, and to comply with the operation code, which is mandated through Indian Electricity Grid Code, which is a regulation in India, which governs the operation of all the generation, transmission, distribution companies. What can be done by powerhouses by operating their generation within the capability of the machine in response to various grid conditions? That is what we'll look at. With the background of the electricity grid code, this was the first approved by the Commission in 1999, and at that time the All India installed generation capacity was just about 90 gigawatt, that is 90,000 megawatt in 2019. Now it has crossed 360 gigawatt. So you can see the power system has grown to a very large extent, multifold actually, since the first grid code was released in 1999. So in accordance with that, the re-notified grid code was released in 2006, and again further it was modified and released in 2010. The 2000 grid code again had several amendments. There are major 6 amendments in the grid code, which basically again related to tightening of the frequency band and various other measures. Also, renewable penetration by that time has become significant, and so one of the characteristics of the renewable generation, as all you know, is its variability, because it's not like a conventional power station where generation is fully in control of the operations, but it depends on the natural phenomena. The major amendments were related to inclusion of the forecasting and scheduling framework, especially for the renewable generation, and if the variability of the renewable generation, how it can be compensated by the operation of the thermal units as well as the hydropower stations which are online. So this was basically necessitated amendments to 2010 grid code with all those 6 amendments which is in operation. Then recently, the draft, there was an expert committee constituted and draft grid code 2020. The report has been released. Some of the measures and recommendations we'll see of 2020 grid code. What are those recommendations? And some of them are already getting implemented. One of the key aspects of the grid code is the role of the load dispatch centers, state level load dispatch center, the regional load dispatch center, and then the national level load dispatch centers in terms of scheduling, monitoring the grid operation, accounting, energy accounting, then supervision and control of the transmission network, then economic operation of the all the power generating stations in terms of merit order, etc. And how do we maximize the economy and efficiency? So if some plants which are economical, they will be higher on merit order, and plants which are not only not economical but inefficient, they will be last in the merit order or even closed for operation. It also has a role in terms of giving open access to the transmission network without any bias or discrimination, and basically the commercial mechanisms which are in place for generation, transmission as well as distribution. Accordingly, the operational practices are followed. In our discussion today, basically we'll be focusing on the technical operational aspect of the grid code, which helps in maintaining all the grid parameters under control. Indian power system, as you know, it operates as now the single power system with all the regions. They are interconnected. So that is one major change compared to the prior to 2010, when the all the regions were operating independently. So So when we talk about grid discipline, which each um, constituent of the power system needs to follow, is basically comply to the directions given by regional load dispatch center and the state load dispatch centers. So there is a grid code as a regulation, and its compliance is monitored by the load dispatch center. That is the role. And accordingly, they develop a set of detailed operating procedures, and the control rooms at various levels at 132 kV and above, they will ensure compliance to the directions given by NLDC, RLDC, and SLDC. At the same time, if any major event occurs at any point at any location of the power station, and the information has to be given to the load dispatch center immediately, so that appropriate actions can be initiated. Because sometimes, to keep the network under control, though the incident may take place at one location, but action could be at any other location. And we'll look at it how this can be done manually as well as in an automated way. Now, you know, when we talk about grid discipline, it basically means keeping the three main parameters under control. That is frequency, voltage, and the load on the network. So these are the three basic parameters which are controlled. Again, historically, if you see the frequency band within which the grid has to operate has been progressively become narrower and narrower. Good old days, it used to be 47.5 and 52.5, such a wide operational band. And you can see that in 2000, it was brought to 49 to 50.5. Now, from that, in 2014, it was made 49.9 to 50.05. And it is further proposed that this frequency control has to be further narrowed down to 49.95 to 50.05. But today it is 49.9 to 50.05. In such a narrow band, frequency is now band is operated. What is the advantage of progressively bringing down the frequency band to such a narrow range? Because as the power system has grown, Indian power system, which was a deficit power system, today we can say it is to some extent a surplus power system. So we have now reserves online which were earlier not available. So that is a sort of a sign of a developed power system. Now this enables actions to be taken at various levels. At generation level, transmission level, and distribution level to maintain the frequency in a very narrow band. It has become possible, and various action and technological development has permitted grid to be operated in a narrow band, and that's how the grid also becomes very reliable and stable. We are all aware of the frequency linked dispatch guidelines, and we started with ABT regime, where there was frequency linked commercial mechanisms also for the scheduled and unscheduled interchanges over transmission line. Further, you must have read the recent news that now automatic generation control, which was piloted earlier, now recently the automatic generation control at the National Load Dispatch Center was also now inaugurated. So apart from automatic load control by way of load shedding scheme, under frequency load shedding scheme, or DA by DT load shedding scheme, there is also now automatic generation control, which is now available to keep. And this has basically become an enabling sort of provisions to narrow down the frequency band. This is one of the latest report you can see from the National Load Dispatch Center, where you can see how the frequency fluctuations. This is the 49.9 level, and this is the 50.05 level. So this is your operating band. So you can see how the frequency is getting controlled within this narrow band. There are some excursion, and this daily report actually gives number of hours frequency which is outside this band. You know, in a 24-hour day, this report that there was for 5 hours the frequency has been outside this band. But this is a remarkable achievement of Indian power system with its growth, that we have been able to operate frequency in such a narrow band, just like a power system in developed countries like in Europe and others. We are almost now at par with those power systems. So at this point, any questions? In order to make it interactive, as Lambaji has suggested, on each of the key points, we can take a 1 or 2 question now, or we can take questions at the end if you are not ready with the question. Any question on this frequency band or frequency operation? If not, keep in mind, we can, as we discussed little more in detail on governor control and full governor mode operation, restricted governor mode operation, etc. You will have little more clarity on this. Then look at the provisions related to voltage control. These are the, again, provisions from the grid code that all users and the load dispatch center shall take all possible measures to ensure that the grid voltage always remains within the following operating range. So there is a nominal voltage and there is a maximum permissible voltage, a minimum permissible voltage. And there are number of set of actions at different level. There is a role to be played by generating companies. There is a role to be played by transmission companies and the distribution companies to ensure that voltage remains within this band. And we'll see what are those various actions which are possible. From the generating station perspective, automatic voltage regulator is one of the key component of the generating plant, which helps in maintaining the voltage at the desired level. So it is mandated that for all the generating units which are 50 megawatt and above size, they should be having all the time AVR in service. So they should not be operated in the manual mode. And for 250 megawatt and above, even it is mandated that in the technical standard mandates that there should be 2-channel AVR. That means there should be redundant automatic voltage regulator operation, just like a main and standby, and controls like power system stabilizer, etc., should be kept in service while on AVR mode. So these are the some of the provisions which are there in AVR from the technical perspective. The second control is governor control. Just like voltage control in the power station, all hydro units, especially, it is mandated that all thermal generating stations for 200 megawatt or above and all the hydro units of 100 megawatt and above, they should be operating at their full capacity, and they should be also be able to take a short time overload to the extent of 105% of 110%. And this is again possible through governor control. And this is basically a full governing mode operation where the machine will respond to the frequency variation in the grid within the available capacity of the machines, including the short time, you can say excess capacity to the extent of 105% or 108%. So these are the provisions which are now available. And going forward, the grid code draft or recommendation of 2020 grid code is basically to completely do away with restricted governing mode of operation and have all the units being operated under full governing mode of operation. So the draft IEGC has suggested that frequency response measure to correct the load generation imbalances in an automatic manner with the help of primary, secondary, and tertiary reserves, coupled with demand response. That means the load side control. In view of the comfortable power supply position, it is now possible to have reserve generation capacity on bar for quick response. National Load Dispatch Center has already taken measures for automatic generation control. So apart from primary response pertains to the full governing mode operation of the power station. The secondary response is through AGC and other means, which is now also recommended to be activated. So these are some of the modified provisions related to frequency control.
Sir,
Yeah.
here my question is,
Yes.
sir, CERC are requesting and already has given the draft to
Yes.
implement the AGC.
Yes.
And sir, AGC and RGMO is a totally contradictory matter. So how it is possible and how the billing will happen from the utility department, sir?
See, the contrary in a commercial way, it will not be if the for the frequency response, if the generation is varied as per the AGC, you are not liable commercially for any UI charges or any other penalties. So the technical provisions also go hand in hand with the commercial provisions. So this AGC will not impact the commercial scheduling mechanism.
Sir,
Because
so theoretically, sir, theoretically it is proved that AGC is not given any effect to the billing of the generations. But sir, practically it is not possible because those people who are working in the control room, they are always seeing the frequency and always they put up the machines in the RGMO. So if the secondary response, you have to maintain the frequency response through the AGC. So it's not possible to back down the generations. And if we back down the generations, then highly negative UI will be reflect on our UI schedule. So this is, I think, sir, the matter is not clear still now, sir.
I agree with you, but what I understand is when this AGC was implemented, correspondingly amendments were to be made in the UI calculations as well as the schedule versus actual deviation calculation if it is triggered on account of frequency, primary frequency response or by the AGC. So of course the people who have, this is a recent 2020 amendment which was very recently now implementation has started. So maybe somebody who is more experienced in commercial mechanism can comment on that. But to my knowledge, commercial mechanism was accordingly has to be amended. Otherwise, it will be the same situation some years back when even the full governing mode of operation, though it was recommended, nobody was actually following it. So that is how it will be. So I suppose with experience, we should be able to see whether these two provisions are actually counteracting. Means one is sort of causing incentive, other means disincentive. That should not happen. Really. Your comment is right, but I am not aware of the actual what are the provisions made in the commercial mechanism to enable AGC. Anybody else can comment who is familiar on that? Any other comment?
Recently, CERC have circulate one circular through IOM in all the power stations.
Yes.
Write the command. So we are going to implement the AGC, and I personally give these commands on the on that particular for the particular against the IOM. But still, there is no solid reply from the governing authority of electricity. And I have also asked the NRLDC, RLDC agency. They don't have any clear-cut reply on the billing. So, finally, we have to suffering, though you are generated properly, but due to AGC, we are suffering the billing problem, sir.
Yeah, you are right. If commercial mechanisms are if not modified, then this will happen. But I suppose if you appeal on that, the view will be view will be taken, because there is always some delay in technical side and commercial side, and sometimes they don't really coordinate together. But I'm sure it will happen in future. Any other question? So RGMO as such was a provision because the full governing mode of operation has not been successful. People were keeping under FGMO the deadband so wide that virtually FGMO was not really getting implemented, because as you said, that commercial mechanisms were actually proving to be counterproductive in full governing mode of operation. And with AGC now, the similar should not happen, and I'm sure provision should happen. But RGMO was basically introduced because of unsatisfactory performance of full governing mode operation, where when the frequency crosses certain limit, the short time capacity of maximum continuous rating to the extent of 105% was utilized so that frequency can be corrected in a short time, and then within a reasonable time of 10 to 15 minutes, you can reduce to nominal capacity of the machine. So that was basically the idea of RGMO. With the power system having online reserve capability now, this RGMO is now basically will be superseded, and with AGC coming into picture, only FGMO will remain with AGC in service. That is the future for operation. But as commercial mechanisms will also be modified going forward. Now that was on.
Sir.
Yeah.
Sir, AGC, the secondary response system, I think it's not a foolproof system, because suppose we are running our machine with full FRL, and we don't have any options, but suppose we are running our machine according to DC. So suppose as our power station has implemented the AGC, and suddenly back down our generations, then spillage is there. So there is no proper answer how we manage that spillage, sir.
Yeah, so for AGC to be implemented in hydropower station, the rate at which this reduction has to happen when the frequency goes high, as well as the load pickup rate will depend on the individual machine capabilities and to suit the power system, so that spillage do not occur, or no pressure rise, or if there are pressure oscillations, etc., they can be avoided. So obviously the rate has to be in a very controlled fashion. But this also will be helpful for thermal power stations which are having online reserve capacity. If they are, as per the merit order, if they are operating on part load condition, they will be the ones which will basically play a role. And the rate at which the thermal power station can vary their generation, increase or decrease, again depends on the master fuel control on the boiler side. So each generating station, whether it's thermal or hydro, the rate at which it will respond will have to go by the recommendations of the respective manufacturers and the type of the plant, so that pressure variations or the spillage, etc., do not occur. That is one of the things. Going forward, the experience will only tell us that which are the power stations where there is limitation, and maybe they will not be then part of the AGC. At the moment, only there some select power stations only have been taken as for AGC control, not all power stations. Small hydros or depend the type of reservoir, depending on their own capabilities, they can play their role. But as a entire power system with the online reserve capacity, it should be helping the grid to maintain the desired frequency in a narrow band. That is what is expected. But of course, these are all subject to amendments depending on the actual experience. To supplement the efforts on generation side, the transmission and distribution companies also need to play a part in terms of loading on the lines, as well as the loading on the transformers, especially the interconnection transformer, because all the interchange of power between different regions at the tie points, they becomes vulnerable, as it was experienced in various grid collapse situations when the overload of certain corridors. So special protection schemes were recommended for taking care of certain contingencies, and we'll be discussing a little more on the special protection scheme. But one of the thing is this is the effort which has to be there on because in spite of the efforts on generating station side, if the bottlenecks are there in the transmission corridor, again it will be detrimental to the stability of the grid. So it's not that it's a generating station alone can play a part. The transmission also needs to provide required control scheme. Special control scheme, protection scheme basically today are taking care of the loading of the line if some transmission outage becomes N-2 type of contingency. That means suppose one transmission line is already out for some construction or maintenance work and one more tripping occurs, then the load has to be brought within reasonable range, and that can be brought either by load shading type of scheme or generation shading type of scheme. Generation shading can be by way of rundown of the loading, and again will depend rate at which it can come down will depend on the each power station's ability without causing any pressure surge or spillage. So this is again the mandate, and we will see more in details what type of schemes are there. On distribution side, basically 33 kV, 22 kV, 11 kV, etc. The actual load can be shared in coordination with the frequency control, which is done by increasing the power. Basically, the load and generation balance can be achieved either by controlling the generation or controlling the load. So the under frequency load shedding schemes are accordingly devised, and you all must be aware there are under frequency, purely under frequency based load shedding scheme. There are also under frequency schemes based on the rate of change of frequency, dF by dt. And those are some of the details given here based on the experience in interconnected power system of India. The rates could be 0.1 hertz per second, 0.2, or it can go to 0.3, 0.4 hertz per second. But if the region becomes split, for example, certain regions get disconnected, like in 2012 grid collapse, the western region and northern region got separated, and then all the power flow went via eastern region. So these type of phenomena can be handled through proper load control measures as well as the special protection scheme, and they have to be very well coordinated with the frequency control measures at the generating power stations and the controllability of the primary control as well as the secondary and tertiary control of the frequency. So all the three stages of frequency control are important to keep the frequency within their desired narrow band. These are some of the measures you can see. This grid code 2020, it gives recommendation for load shedding schemes starting from 49.4. So you can see that from 49.5 your narrow band of the operation starts, and just below that 49.4 and in steps of 6% of all India demand, the load has to be shared as the frequency goes down from 49.5 to 49.4, 49.2, 49, and then 48.8. And this is the quantum of load shedding. So almost 25% load can be shared with this under frequency load shedding scheme. That is what is proposed. The important aspect of the discipline is also in terms of estimating the demand. So the grid code also mandates that the mechanism and load dispatch center will do the load for demand for load or demand forecasting based on the season and types of load, commercial load, agriculture load, industrial load, etc. And especially the renewable power generation scheduling based on this load forecast also has to schedule their generation based on the wind forecasting or sun irradiation forecasting, etc. So forecasting of generation as well as forecasting of the loads becomes an important technical parameter, and there are various methods how this forecasting can be improved. So demand estimation as well as generation estimation, especially from renewable. Going forward, this is going to be even more complex because of distributed generation, because now even the rooftop solars are coming up. There are distributed generation sources at the distribution level also. So estimation of generation as well as the demand is one of the key challenges as when we talk about grid discipline. So there is a demand side management which is going to be one of the key aspect going forward. Apart from load shedding scheme, there are various demand management schemes which are going to be rolled out even in future for the commercial load, industrial load. Demand side management also ensures that essential and non-essential loads are properly dealt with, so that non-essential loads can be shared as and when there is a need, whereas the essential loads, for the sake continuous process industries, or it could be railways, or it could be hospitals and things like that, they can remain in service as much as possible, rather than shutting down the entire load in certain areas. So this is going to become more and more intelligent and adaptable to type of load which is being served. We talk about system resilience, so that we talked about special protection scheme. So this is actually the wording of the technical provision in the grid code, where CTU shall analyze N-2 contingencies which could lead to cascade tripping. So the cascade tripping, which was a very regular phenomena at one point of time, I think over a period of time now, with various schemes, protection schemes, as well as the special protection scheme, they are being minimized. And along with this, there is also a provision to have controlled isolation of the regions and areas, including black start provisions from certain power stations to restore the supply after certain area faces complete shutdown. So restoration procedure becomes another important aspect of this grid discipline, how the load should be restored. So again, the RLDC and state load dispatch centers, they make a restoration procedure after collapse of the grid, whether it's a partial blackout or total blackout. The roles of various generating stations, as well as transmission and distribution companies in terms of restoration of loads. As I said, essential load, non-essential load, and when you do the black start for certain power stations, the procedure for black start, what sort of black start facility will enable certain loads which are related to the auxiliary power for the identified power stations, basically power plant auxiliaries which require startup power, how they can be resumed supply from the identified power stations. And also when you energize the grid with the black start facility, how the synchronization back to the grid can happen once the other regions are synchronized. So this becomes all part of the restoration procedure. Scheduling responsibilities, RLDC, SLDC I had already mentioned. Who will control central generation and state level generation, that is all spelled out here. This doesn't really require clarity. This is a very much a provision which is being followed.
सर ये सतीश कुमार श्रीवास्तव का हैंड रेज है बहुत देर से, जरा काइंडली उनसे पता कर लेते हैं क्या है.
I didn't get.
ये सतीश कुमार श्रीवास्तव.
हाँ.
ये श्रीवास्तव जी, यदि अपना कोई क्वेश्चन है तो पूछ सकते थे, आपने हैंड रेज किया हुआ है काफी देर से.
अच्छा, okay. You can ask the question now. We basically in terms of what we discussed just now in terms of load generation control. Satish Kumar ji, you have any question?
ये लगता है गलती से उनका हैंड रेज आ रहा है से।
ठीक है, as and when he is ready we can.
ओके, थैंक यू सर।
Yeah. So the grid code also specifies now that the special requirements of solar and wind generation. Basically, the priority has been given to renewable generation so that they should not be backed down. In case there is a requirement to run down certain power stations, these come under the category of must run power stations, renewable generation, because we don't want to waste any renewable energy. Similarly, the requirement of reactive power generation and drawal, especially wind power station, they draw their excitation from the grid. So they draw actually the reactive power from the grid. And sometimes it becomes a difficult task if you have got major wind generation and reactive power, there is a shortage, then the voltage becomes low and controllability becomes difficult. So there are certain provisions related to backing down of the active generation. At the same time, the reactive power flow, how it can be managed for the renewable generation. The only provision which has been renewable generation, it comes, as I said, it comes under the must run power plant category. However, if there is a transmission system constraint, the renewable generation may be curtailed after whatever resources are available to evacuate renewable generation. Otherwise, if there is a transmission bottleneck, they even the renewable generation will have to be curtailed. Then comes the question of reactive power management. Now, this is something which is not really satisfactory as far as the incentives are concerned to manage reactive power from the generating power station perspective. There are provisions in the transmission system by way of reactive power compensation. After 2012 grid collapse, you must be aware that SVCs, static work controllers, as well as the STATCOMs, static compensators, are being put in service at various 400 kV substations. Reactor controls at 400 kV bus bars, as well as the transmission line reactors, they also help in controlling the reactive power flow and controlling the over voltages during light load conditions of the line. Reactive power generation from the generating power station, incentives in terms of say 10 paise per kilowatt hour, etc., are not really very attractive, and this has not been much success, I would say, in India at least, unless we'll come to the topic of ancillary market, ancillary services, and voltage control ancillary services. If they are attractively priced, then the reactive power generation as well as the reactive power absorption at the generating stations will become incentivized for the generating station. Otherwise, especially for hydropower stations which are remotely located and the load centers are much away, producing reactive power and transmitting it over to long distances to the load centers becomes non-remunerative and generally then not followed. again losing the reactive power resource to control the voltage levels in the grid, because transmission system alone is not able to generate, because it requires a lot of capital investment. Though it is being done to some extent, that is not sufficient unless the generators also participate in the reactive power management. There are provision in the grid code regarding the trip analysis. You all must be familiar, because occurrences and incidences need to be informed, as well as the protection actions, etc. Disturbance record, event record, they have all been mandated at all the power stations, so that analysis can be done. This helps in improving the system, as well as for quick resumption of power after the tripping. So in both ways it is useful. We already talked about the provisions related to demand estimation for operational purpose. This is the wording copied from the grid code. This is only for your reference. You can read this separately. Also, the provisions related to demand disconnection. There are these are the provisions from the grid code. And as I said, there are four groups of load said to be tripped based on the under frequency and dA by dt. The under frequency relays and dA by dt relays. We saw those proposed settings of the frequency at 2020 amendment recommendations of grid code. Provisions related to responsibilities again related to the interstate transmission system, evacuation of power from ultra mega power stations. The recent initiative has been also to strengthen the green power corridors, so that this ultra mega or mega solar power stations and wind power stations, hybrid power stations, they can be evacuated on priority. The new grid code also has provisions on cyber security. Again, this is a topic which has become crucial in view of the number of digital automation systems for plant control, as well as for the transmission network control, the load dispatch, system control. So cyber security measures and discipline. This is the provision related to protection code in the grid code, in terms of protection philosophy, protection settings, protection audit, and special system protection schemes, the recording instruments. These were all recommended as part of the recommendation of the 2012 grid collapse, and subsequently incorporated in the grid code. Reference is also made for the protection philosophy and protection setting to the CBIP manual on protection, which is taken as a reference manual. It is mentioned in the regulation and grid code. These guidelines should be followed. The protection manual which CBIP committee had come out, and that was amended, and the latest version was released in 2017. And the automation manual was just released, I think, few months back. Both these expert groups, I was chairing the committee, which Lambaji had mentioned. Yeah, so these are some of the key provisions we saw on the grid discipline side, which are made through the grid code. Are there any question on this? The next topic which we'll try to cover before break is the generator operation within the capability of the generator. I talked about reactive power support, which generator can provide. Any question at this stage?
अपने पावर स्टेशंस की जो प्रॉब्लम्स हैं वो भी कुछ डिस्कस कर सकते हैं आप लोग रिगार्डिंग दीज टॉपिक्स.
Okay, you can still think. At the end of the session, again, we will come back to the question.
Okay.
We'll look at now as a power station operation. We talked about as a grid discipline in order to maintain the voltage, frequency, and loading on various network parameters. What are the provisions for everyone to follow? Now we'll see as a power station operation. What can be done by power station to maintain the grid discipline? When we talk about the capability of the power station, it starts with the key parameters of the generator. The key parameters also are their various impedances, etc. We need to be aware what is the implication of these impedances as far as the grid discipline and grid operation is concerned. And we'll talk about that. These are some of the, what is listed here is the constructional features of the different types of generator and their excitation system. Basic generator electrical model. So this is the generator reactance and resistance state of the stator. So this is your basically representing the armature, and this inductance and resistance is mentioned as a your rotor parameters, and this is shown as variable because the excitation control is basically shown as a variable resistor. So this is a simple equivalent circuit of a synchronous generator. When you represent a generator with its R and X, and this is your terminal voltage. So you can see that there is a voltage which is Vt. Add to that the voltage drop in the resistor and voltage drop in the reactance of the generator, and you get the internal voltage or EMF of the generator. So this is E. So this is the internal EMF of the generator, and this is the terminal voltage. And this reactance and this resistance governs this angle between Vt and E, and this becomes your load angle. So idea of explaining this to you is basically this is your key parameter as far as the generator operation is concerned, and generator ability to deliver MW as well as the reactive power is basically governed by the capability of this equation and the sign between E and Vt. This is your load angle of the generator. This is basically the purpose of this slide. The same phasor, depending on whether you are running the machine at the unity power factor, which is represented here, or the lagging power factor when you are exporting the reactive power, or the leading power factor when you are actually absorbing the reactive power. This is shown here, and this further gets converted into a diagram which is called capability curve. These slides basically show how the from this basic equation how the capability diagram gets generated, but ultimately a generator capability curve which is used for the operation purpose is given by then the ability of the generator to produce active power at various reactive power depending on the excitation. So if it is overexcited operation, you can see this is the capability of the generator to generate reactive power for a given active power. Generation of reactive power in the overexcited region is basically limited by the excitation limitation as well as the field current limitation. And along with active power and reactive power, the armature current, which is the stator current limiter. So the capability in this quadrant gives you how much reactive power can be exported for a given active power, as well as while remaining within the current rating of the winding, armature winding. Similarly, on the under excitation side, how much reactive power you can absorb. So when you operate the machine in under excited region, you are actually absorbing reactive power from the grid. That means the grid voltage is higher and generator terminal voltage will be lower. So you are operating under excited. What it means is your excitation torque is weaker and weaker as you reduce the excitation. So the final limitation on under excited side is basically the stability limit. That means if the excitation becomes very weak, then your ability of the machine to remain synchronous with the magnetic field of the armature, no more they will remain synchronous, or they will get decoupled when excitation power is very weak. So that is the stability limit. But before that, there is a limitation on the generator in under excited mode, where because of the reactive power being taken from the grid, the end region of the stator's core, the slot of the machine, there is a heating due to excessive magnetic field, and your end region of the generator will become overheated, and that is basically the fear because of which usually the generating units, people are hesitant to operate in this under excited region. And we'll come to this capability curve again. So we discussed this regarding the lagging, unity, and leading power factor and its effect on the regulation.
Sir, one question on that particular point, sir.
Yes.
Suppose our machine is running in full megawatt.
Yes.
And suppose the grid is asking more MVAR. So
yes.
This is our prime responsibility to support the grid, sir.
Yes.
So in that case, if how much we will support, or we will immediately contact with the RLDC, ki our machines is asking high MVAR, grid is asking high MVAR. So you please regulate it. So how they regulate the MVAR, and when we should intimate them ki yes, MVAR is too much is collecting from our machines.
Now, this is as far as power station is concerned, the effect of reactive requirement from the grid will get reflected on the voltage at the terminal. So what you will see is, suppose your AVR, if your machine is say 11 kV generator terminal voltage, and you will see that generator terminal voltage based on the generator transformer tap is becoming lower and lower. The voltage is becoming lower. And so to maintain the voltage, generator will start pushing more reactive power. So your guidance basically will be this limit as it approaches, you have to inform the operator, that is your load dispatch center, that the voltage level in the grids are low. So my generator is generating more reactive power. So they need to advise you what measures can be taken in the network so that generator side requirement can be. Yes, sir. Some of the hydropower system where there is a on-load tap changer on the generator transformer, you may also resort to on-load tap changing operation so that reactive power export can come down. Or on the grid side, if the reactive power sources are available, then the grid operator, that is the load dispatch center, will take action on the network side so that the voltage level will improve and your reactive power generation requirement will become lower. Overriding all this is basically, if you normally we recommend that at a 10% lower level, over-excitation alarm should be set. So if this is your capability limit, over-excitation limiter is set at this in the AVR, that is automatic voltage regulator, 10% below that you should have an alarm so that you will be alerted that you are approaching the over-excitation limiter. So this is the, I would say, 3-stage protection and control. First is the over-excitation alarm, then the AVR, over-excitation limiter will be in the picture, and then the action, manual action, which is to be taken on the grid side will be taken. So these are the 3 levels of control, and the moment you get an alarm at the first stage itself, you should contact load dispatch center. Right?
Sir, the different machines have a different characteristic and different capability curve. So
Yes.
how they measure the MVAR range? So this should be minus range and this should be plus range. Is there any design aspect, sir?
Yeah, there is a design aspect, and the choice is basically based on the initial choice of type of generator which you choose, and type, and that also goes by the type of turbine which you choose. And once you make that choice, then the manufacturer will give you the capability curve which has to be then followed. So this is basically planning decision which is made, and we'll come to a few slides afterwards, the short circuit ratio, which governs basically the size of the machine, the air gap, etc., and which decides your synchronous reactance as a parameter based on the leakage reactance, etc. So these parameters also drive the cost and the size of the machine. So this capability curve has also direct implication on the choice of your generator parameters in terms of short circuit ratio, as well as the type of cooling and the type of turbine. So once it is design choice has been made, then the capability becomes fixed, and you have to follow this type of chart given by the manufacturer. Does it answer?
Yes, sir. Yes, sir.
Okay, so I talk about the power transfer relationship with the sine delta. Delta, as I explained to you, is the internal angle between the EMF of the generator and terminal voltage of the generator. This becomes your synchronous reactance of the machine. And the power transfer is basically this is the equation, E1 E2 the reactance and sine of delta, and this is the sort of then the curve. Your power transfer is maximum with delta, the load angle is 90 degree. sine 90 is 1. So the maximum power can be generated when delta is 90 degree. Above 90 degree, machine will become unstable. Usually the load point of the generator would be around 60-70 degrees, and that is the optimal point which will keep enough stability margin so that machine doesn't lose synchronism when there is a fault. The basic parameter for this is X by R ratio. So basically this reactance and the X bar R ratio which influence the this thing, and this load angle, if you further consider between, say, okay, before we come to load angle, I will explain the other parameter which is called open circuit characteristic and short circuit characteristic of the machine. Basically, this open circuit characteristic is the excitation field current required for the open circuit voltage to get generated, and this is the sort of a voltage versus field current curve. This is the OCC, which all you must be familiar. Then when you put a short circuit on the generator, then to drive the rated current in the short circuit, what is the excitation required? That becomes another parameter. So the short circuit ratio is basically the field current required for generating rated open circuit voltage. Below that is denominator is field current required for circulating the rated short circuit current. This becomes a short circuit ratio, and if we go by the mathematical equation, this actually becomes inverse of your direct axis reactance or synchronous reactance. So short circuit ratio as a thumb rule is the inverse of reactance. What it means is higher the reactance, lower will be the short circuit ratio. What it also means, these are the typical, say, short circuit ratios for hydro machines. For a thermal machine, these ratios will be less than 0.5, 0.4 or 0.45, etc. Hydro machines is this. Now, basically, this reactance, short circuit ratio is the inverse of reactance, and this synchronous reactance basically is based on the diameter of the bore of the generator, stator winding, and the diameter of the rotor winding, and this resultant air gap, because that is what will decide the field current requirement. Depending on the air gap, how much field current needs to be pushed for a given flux density, air gap flux density, and that is how the size of the field winding will get decided. So the short circuit ratio is the key parameter when you purchase a new machine, which will give you the better performance. Higher the short circuit ratio, better the performance in terms of stability, but the mass of the generator becomes bigger, so it becomes a costly machine also. So it's a, you can say, techno-economic decision at a planning stage, and these are the various significance which are listed here, which you can read through in detail. So short circuit ratio, as you said, becomes an important parameter as far as the capability of the machine is concerned. Then comes the line charging capacity and the condenser capacity of the machine. Now, the grid code also mandates that hydropower stations especially should have capability to operate in the condenser mode. At least the power station which are 50 megawatt and above, they should have ability to operate in condenser mode. What it means is basically your turbine side, hydraulic side, basically it will be just turning in the pit. So the resultant losses should not be causing any damage to the turbine. while the condenser operates in only generating reactive power. So it acts as a synchronous condenser, means it can export reactive power or it can absorb reactive power. So this is one way of harnessing generator as a resource for controlling voltage by either supplying reactive power or absorbing reactive power. But this is not generating any active power in this case. The capability curve gives you the capability in reactive power absorption as well as export of reactive power while generating active power. Whereas synchronous condenser mode becomes a attractive proposal if there are good incentives to provide reactive power. For example, when hydropower stations are not running to conserve water, say in the dry season, you want to conserve water, the hydropower station can be operated in condenser mode and you get a good tariff for as a ancillary service for maintaining voltage. You have additional revenue for the power station, though you are not generating any active power. So this is one of the capability which can be very useful. The generator has a capability in terms of its ability to supply short circuit current. You are all aware that generator has a sub-transient, transient and steady state operation. The peak current of the short circuit current, when you say 40 kiloamp short circuit current, it is a steady state level. So short time rating of all your equipment will depend on the steady state, which is a short time rating, 2-second rating, 3-second rating, or 5-second rating of the equipment. Whereas the sub-transient period is the peak value, which is more than 2 times the steady state value of the fault current. So all your dynamic forces on account of electrical current, mechanical forces will depend on the peak current. So transformer winding, for example, has to withstand peak magnetic force generated due to this sub-transient current. Whereas the transient period, this current is important for the purpose of protection actions. As you can see, this time period here, which is after few cycles of the short circuit, this is the time when your protection will be active, and this decrement in the fault current is one of the aspects which has to be taken care of by the protection settings to take care of this. So this is the significance of the you can say short circuit current characteristics. And AVR we already discussed. Under excitation limiter, over excitation. These are the slides which you can go through. They are important to know what are the operations which are possible within the capability. So these limiters will be useful. From the excitation perspective, again, the response of the excitation system to the grid fault is one of the performance parameters. So when you say operation of the power station for grid condition, the ability of the generator to remain stable while it is feeding the grid fault depends on the excitation response. And these are the 3 parameters of the excitation response: the response ratio, the ceiling voltage, and steady state and transient stability condition. So this is the AVR response. So this is the rise time from 0.1 to 0.9. This is called the rise time. This is called settling time, when there is an overshoot and then it settles down to steady state value. So this is the characteristics of the AVR. That is why we always insist to never operate a generator in the manual mode, because you will not have this sort of controllability, and machine will become overstressed, or it will not be able to contribute in a stable manner. So I think at this stage we'll break. In the afternoon we'll talk about stability, and we'll also look at the other aspects. Any questions now before we break for, and we afternoon session will start at 2:30. So we'll take some questions before we break for lunch. Any questions?
जिनके क्वेश्चन है वो काइंडली कीजिए, जो क्लैरिफिकेशंस लेनी है.
Sir, I am Prabhat Kumar from Parvati 3 Power Station. I have a question. You talked about the frequency range band, which is 49.95 to 50.05. Is
Yes.
this frequency is a average frequency in a block or instantaneous frequency?
It's the instantaneous frequency.
Okay, but nowadays we are noticing that grid frequency is going from 49 point, even sometime it goes to
You can see.
49.72 to.
Yeah. So this is see, this is the chart. That's why I showed you that this is the frequency band 49.9. This is the band, and you can see this is the instantaneous frequency which is being controlled within this band. And there are occasions when frequency has gone down. For example, at this instant, the frequency had gone down to 49.7 also.
Yes.
So these are instantaneous value. Attempt is to keep the frequency within this band. And this daily report from National Load Dispatch Center also gives number of hours the frequency was outside this band. You can see for 5 hours it has been outside this band. So
basically,
this is how it
this
is to be
is
seen.
instantaneous. One thing it is clear to me that
this is instantaneous.
Yes, yes. But it means nowadays we are working out of frequency range most of the time.
No. You can see the effort is to remain. You can see the though this is very much magnified here, but you can see 49.7 to you can see 50.1 compared to good old days. This is a very tight range in which frequency is very stable. So, but you can say out of 24 hours, 19 hours it has been within this band. So quite a stable operation, I would say.
Okay, sir. Now it is clear to me. Thanks.
Sir.
Yeah.
Excuse me, sir. Sir, actually, what other measures can be taken at a power station side if the generating units are reaching its capability curve, other than ending RLDCs?
अपने आप को इंट्रोड्यूस भी कर देंगे पहले तो ज्यादा बेटर रहेगा. अपने
Sir, I am Pradesh Shamas from Uri Power Station.
Yeah. Okay. So I think what can be done within the capability curve, you said?
Yeah, if capability curve is reaching, and what measures can be taken from the generating station side if it is reaching the curve?
Within the capability curve, basically you have the controllability on VAR as well as the load based on the governor setting and the AVR setting. So, for example, if you are having a voltage issue, then the AVR voltage set point, normally the range of voltage control AVR set point is say 185% to 105%. So within that range, you can keep the voltage set point fixed so that control can be around that reference voltage. So that is one control point. Second point, which will affect the reactive generation. The active power generation, similarly, in the frequency group setting, the reference frequency band can be up and lower. So you can change the reference frequency setting on the group set point of the governor characteristic. Again, depending on that, then the load variation, if you are on full governing mode of operation in future, rather than block load operation, that will be your controllability within the capability curve by changing the governor set point. Then finally, in terms of the again the voltage, if you have got a on-load tap changer, then you can change the voltage tap on the HV side of the generator transformer. Again, which will change the voltage as seen by the generator. Again, it will affect the basically reactive power flow. So these are the three type of actions which you can take from your side. And sometimes there is a limitation on the line loading. For example, if you have got say 4 lines which are evacuating the full power station, and there are some say 2 lines trippings occur, then you will have to control the load through dropping the generation. Those are your usual load set point control to keep the loading on the lines within the limits. So these are all the actions which are possible from your end. Right?
So how the megawatt affects the MV by changing the megawatt? It doesn't affect the MVR
No.
generating, right?
No, it doesn't. Both are independent. Both are independent.
Then how will it help in reducing the MVR of the generating units?
No, by changing the governor set point, MVR doesn't change unless you also change. Unless you change the AVR set points also at the same time.
Okay, then you said the megawatt should be reduced. Then that doesn't help, right?
Megawatt reduction is for the purpose of limitation on the loading of the line. In case, suppose you, as I said, there is a evacuation limitation because voltage in the transmission line, then you can reduce the MW generation so that line loading becomes within the capability of the line. So it's not only the capability of the machine, you have to see the capability of the generator transformers and lines also. So that's why I said. But AVR control, voltage control, and the active power control on governor, they are two independent.
Sir, if anyhow, if the MVR still not coming under control, what should be done?
No, then you just stay put within your capability limit. You will not be then supplying. You keep changing the AVR frequency. Your export of power, reactive power will remain. Otherwise, suppose grid voltage keeps sinking, then your excitation system will keep boosting, so that more and more reactive power till it hits the over-excitation limiter. That's why I said before over-excitation limiter is hit and excitation is limited, you should get an alarm at 10% less value, and you can block the further boosting of excitation control. In some of the AVR control, there is also another control mode which is called reactive power control mode or power factor control mode. So instead of voltage control, then you can switch to reactive power control mode so that it will not respond to voltage change. It will keep generating fixed reactive power.
So in that case, the voltage will go up. Suppose the rated voltage is 13.8, it can go up to 14 or more 14. Then it will affect the insulation and all, right?
Yes, if you are on the block excitation control, that means the reactive power control or power factor control, and if the voltage keeps going up, in that case you should then start reducing the reactive power, so excitation current will come down. In that case, you switch over to voltage control mode and reduce the set point of the voltage so that voltage on the generator terminal will come down. Voltage on the grid side can remain high, but voltage on the generator terminal can be reduced by reducing the excitation.
Okay.
Second session we will starting at 2:30. तो can we close now? यदि क्वेश्चन यदि किसी के रह गए तो नेक्स्ट सेशन में ही पूछ सकते हैं वो.
Yes, yes.
So now we can close this first session.
Yes.
And we'll start sharp 2:30. तो काइंडली 5 मिनट पहले सारे अपनी जुड़ जाएं इसमें, so that कि there is no wastage of time. Thank you, Patki sir, for this session, and we will meet in the second session now.
Okay, I will log off and I join again at 2:30.
हाँ, यदि किसी का क्वेश्चन रह गए तो in that he can ask in the second session.
Yes.
Okay, sir.